Okay, good morning Year 9. So today we are going to pick up from where we left off. So last lesson you were doing surface areas of cuboids, surface area of triangular prisms. Okay, today we're going to keep moving with surface area, but now we're looking at different types of prisms. Okay, so for your starter, here is another prism. We call these a compound prism because it's got a compound shape on the end. That's the repeating cross section. So I'd like you to try and draw this as accurately as you can. And the first thing I'm going to ask you to do is to find the volume. So you need to think back when we did volume of 3D shapes, 3D prisms. How do we find the volume? Okay, have a little look back in your book if you need to, or get straight into it. Hit pause, and then when you've finished, have a look and see if you've got it right. Okay, so in order to do this question, the first thing we need to remember is the formula for volume. So volume is the cross-sectional area. So in this case, where you can see it saying A and B, just there, cross-sectional area multiplied by this length of 30 centimetres. So we get area of A plus B. So the area of A is 2 times 3, which is 6, and the area of B is 6 times 4, which is 24. And then the length we've got as 30. Multiply 30 times 30, we get 900 centimetres cubed. Don't forget the units, and then we're done. Okay, now we're going to use the same 3D solid and we're going to find the surface area. So you can imagine it gets a little bit more complicated. We have to really think about all the different surfaces. So here I'm going to use the same technique that I do for cuboids. I'm going to label my surfaces. So I'm going to call this cross section where A and B are, I'm going to call that side 1. And we've got another one here. Okay, I'm going to call that 2 on the other side. So they're actually the same. And then I'm going to look at all the different faces. Got one here. I'm going to call that, let's call that 3. We're going to call this side 4. Now let's think of the ones that we can't see. We're going to have one underneath here, which is 5. We're going to have another one on this side, inside of B, 6. One underneath there, my 7. And one over there, 8. So we've got 8 surfaces, 8 different sides or faces, I should say, to consider. So now let's just go through them one by one. So 1 is going to be, actually we worked that out for the volume, 2 times 3 for A and 6 times 4. So 2 times 3 plus 6 times 4, which equals 6 plus 24, which equals 30. And we know that side 2 is the same, so we can say that's 30 as well. Now let's think about side face 3. So it's the length of the prism, which is 30, and then its other side is going to be 3 plus 4. So we're going to have 30 times 3 plus 4, which is 7. So 30 times 7, 210. Then we've got our fourth side. So that's 30 by 6. Okay, so 30 times 6, 180. Now our fifth face is the one that we can't see, but it's underground. So 4 is going to be this side, and 30. So 4 times 30, which is 120. Alright, and the sixth face, which we also can't see, but I know if this is 6 and the other side is 2, that length has got to be 4. So I can write 4 times 30 again. Okay, so that gives me 120. The seventh face pointing up, we've got 3, and then it's going to be the same as the length. So 3 times 30 is 90, and our last face 8, number 8. Okay, and that's going to be 2 times 30. Okay, good. So we've got lots of faces there. I'm going to cheat and use my calculator. So 30 plus 30 plus 210 plus 180 plus 120 plus 120 plus 90 plus 60, and that gives me 840. And don't forget the units, centimetres squared. Okay. Now, some of you might be thinking there's an easier way. And there is. There is an easier way to think about it. But the only reason why I don't show this first is because you've got to think about it very carefully. Sometimes it does work, sometimes it doesn't. So if you're happy with this method, I would recommend that you just carry on with this method. It might take a minute, 2 minutes more, maybe a minute more, but it's worth it because it means that you're not going to be complacent and make any mistakes. So the other way of doing it, if I just get rid of all our labelling now, like so, and I'm going to help you see this by changing my colour, go green. What we can do is actually move these faces. It's these two sides, this one and this one, which we could actually push out. If I imagine that that length, which is, let's see, all the way there, you can't see it because it's on the other side. If I imagine that stretched out there, if I move that face over there, it would actually then join up with this 2 centimetre and be the same as this side. And similarly, let's go with an orange. If I use this face here, and if I brought it down over here, it would combine with this face and it would look like the top. It's not quite easy to see or explain, quite difficult to do on a video without some jazzy diagram, but essentially if you think about the faces when you join them up, they create the same as this top one and the side green one. So actually our surface area could become much quicker for our surface area calculation, because what we end up with is our cross section. So that was A plus B, and 2 lots of that, because 1 on either side, and then actually we get 2 lots of this. Let's call this C. We actually get another C on the other side. And then we're also going to get this one, which we'll call D, and underneath, which we'll call D. So if I carry on working those out, We know that A plus B was 30, so we've got 60 for this part. Well, C, we worked out 30 times 6, which is 180, times 2. And then we have D, our top surface, which is 30 times 4 plus 3, so 40 times, 30 times 7. And then we also have to times that by 2. So we get here 60 plus 360 plus 210 times 2, 420. And what does that give me in total? So we look, 60 plus 360 is 420, plus 420, 840 centimetres squared. So two very different methods. My preference is the first method if you're finding this a little bit tricky. The second method, some of you will understand and find it much quicker. It's completely up to you. I would just say use that second method carefully. Okay, so have a look at this shape. Now this might be a little bit tricky to draw. If some of you feel confident, please go ahead and have a go at drawing it freehand. If you want, you might be able to, if you're on tablets or something, you might be able to trace the screen, or alternatively, if you have access to a printer, you might want to print this out. I'll leave that up to you. So how to find the surface area of this shape? Well, first we're going to consider the two ends. So we've got this shape here as our cross section. So if I label that 1, and I know I'm going to have one on the other side, 2. And then let's think about all the faces. So I've got here 1, 2 on the other end. I've got 3, 4, 5, 6 there, it's hiding, 7 on top, 8. And I've got one big surface on the bottom and one big surface on the side. So in this situation I have 10 different faces to work out. If you'd like, hit pause and see if you can do all 10, all 10 of those faces. Okay, let's see if you were right. So face 1, what I'm actually going to do for this, I'm going to consider a large rectangle, like so, and I'm going to subtract that smaller square. So what happens, what do I get? I get 8 times 6, subtract this 5 times, what would that length be? Let's have a little look. It was hiding. There's that 3 just over there, and that means that must be 3 as well. Oops. So 3 times 5. Okay, 8 times 6 is 48, minus 3 times 5 is 15. That'd be 33. Then I've got my face 2, which is exactly the same, 33. Now my third face, so my length of this shape is 10, so that's going to be 1.5 times 10, which is 15. My fourth shape is 3 times 10, which is 30. My fifth face is 5 times 10. Actually, once you get started, it's not too bad. It doesn't take too long. My sixth side is going to also be a length of 3 times 10, gives me 30. My seventh side is going to be 1.5 times 10, 15. My eighth face is 6 times 10, 60. My ninth face on the bottom, it's going to be 8 times 10, 80. And then my other side, which is the same as 8, 6 times 10, same as face 8, so 6 times 10 is 60. And then I just have to add these up. So I'm just going to grab my calculator and add these up. So 33 plus 33 plus 15 plus 30 plus 50 plus 30 plus 15 plus 60 plus 80 plus 60. And my final answer there, 406 centimetres. Well, actually it doesn't say centimetres. I'll just pretend it's centimetres squared. Really, we could call it just square units when we don't know what the unit is, but we'll just say centimetres squared here. Okay, now we're going to have a look at a cylinder. So we've got here different surfaces to consider. Now this shape, it looks more complicated than it is. First of all, what kind of shapes have we got to deal with? Well, let's think about our faces. I've got this obvious one, this circular face at the bottom, and don't forget, I've got exactly the same again on the bottom. Sorry, it's one on the top, 2 on the bottom. Now what about this curved face? I want you to imagine if you had a dear me, excuse me, if you had a cylinder and you cut it down this face and you rolled it out, what kind of shape would you get? Yeah, if you expanded that out, you'd actually end up with a rectangle. And that rectangle would wrap around these 2 circles. So how we'd make a cylinder, we're thinking about its net now, is that this length would wrap around this circle. So that might give you a clue of how we find out the area of our third face. So just have a think, how are we going to work out the area of that third face? So this length we know is the same as this length, so this is 12. Now the length of this part is what we need to think carefully about. If it's going to wrap around that circle, what's another name for the length that wraps around a circle? That length is going to be the circumference of the circle. And here we go, we've got to try and remember the circumference of a circle formula. Some of you might remember that phrase that we used, chicken pie for dinner. Circumference equals pi times diameter. So in this case, our circumference is pi times, and our diameter equals 4. Well, actually 4 is the radius, so we need to multiply that by 2. 4 times 2. So my circumference is 8 pi. So now we need to put all of that together and go back to working out our surface area. So the surface area for this prism, well, it is a prism, but it's also called a cylinder, is going to be 1 plus 2 plus 3. My surface 1, well, what's my area for a circle formula? Remember that rhyme, or that phrase? Apple pies are squared. Area equals pi r squared. So in this case, our radius is 4. 4 squared gives me 16 pi. There we go. So surface 1, 16 pi. Surface 2, also 16 pi. And now we can do our section 3, which is going to be that rectangle. Now one side is 12 and the other side is 8 pi. Okay, so we can now add this up. 12 times 8 is 96 pi. Let's write that down first. So what is 96 pi plus 16 pi plus 16 pi? We get 128 pi, which is equal to 402 point, let's go with one decimal place, 402.1 centimetres squared. Just see that at the bottom of the screen. Okay. Right, our last example shape today is going to be this triangular prism. Now this is going to involve a little bit more maths. On last lesson on Friday, you did triangular prisms where there is a right-angled triangle. Now in this case, we have an equilateral triangle. So we need to think about the faces carefully. The first three are actually quite straightforward because an equilateral triangle means that this length is 5 centimetres and this length is 5 centimetres. Oh, I didn't tell you to pause, by the way. Please pause the video and actually copy the shape out into your books, and then we can work it out together. So our faces, we could have this side here that we can see, this side here that we can't quite see, and the bottom. That's our third face. And then we've got these triangles on the end. That's going to be my fourth face, and that one on the other end is exactly the same as 4. We're going to have our fifth face. So we can work out 1, 2 and 3 fairly easily. Face 1 is just 15 times 5. So 15 times 5 is 75. And actually we can see that 2 and 3 are going to be the same. So 75 and 75. But sides 4 and 5 need a little bit more thought, because in order to work out the area of an equilateral triangle, we need to do something special. Does anybody have a guess? Yes, some of you may remember, in order to work out the area of an equilateral triangle, we need to use our old friend Pythagoras. What I'm going to do is create a vertical line so that this now becomes 2 right-angled triangles. If I draw that out here, so now I know that the length of this hypotenuse is 5 centimetres. Can I say what this length is? Well, it's actually half the base. So if this was an equilateral triangle, which is 5, this length here for the second triangle is 2.5. And in order to find out this length here, that's going to help us find the area of this right angle triangle. So I'm going to use Pythagoras. A squared equals the hypotenuse minus that other length. So I'm going to use my calculator here. 5 squared minus 2.5 squared. That gives me 8.75. So my A is the square root of that. I'm going to leave it as the square root of 18.75 so I don't lose any accuracy. I could write it as a decimal, but the moment I do that I have to round, and that means my accuracy will be lost. So I'm going to leave it as the square root of 18.75. Now to find the area then of that triangle, I'm going to stick with my normal triangle formula, half times base times height. So in this case, half times the square root of 18.75 times h, my height. Oops, sorry, I've got that the wrong way round. Apologies. My base in this triangle is 2.5. Doesn't really matter. But let's try and be accurate. 18.75, which now I don't mind rounding at this point. So half, I'm going to cut my calculator, half times 2.5 times the square root of 18.75, and that gives me 5.41. So to find out the area of my equilateral triangle, what do I need to do? Well, that's right, I need to double it. So that gives me 10.8253, etc. if I kept going. So that was a lot of work just for that one face, but thankfully I can use it twice. So let's get my cleaner. So we've got here 4, we've done all our working out, we must show all of that working out in blue. So we're going to write here, working out below, and the final answer, 10.82. I'm going to keep it a little bit longer so I don't need to lose any accuracy yet. And then my fifth face is the same as number 4. So that also equals 10.8253. Whoops. And when I add that all together, let's see what I get. 75 plus 75 plus 75 plus that long answer again and again, and I get 246.6506. I'm going to round that to 246.7 centimetres squared. Okay? So take some time if you need it to understand what's been done. Write down the full working out in your exercise books. Okay, if you have any questions, you can always catch me in our Zoom meeting room. I'm there, and I'm happy to go through this with you again. Okay. So because of time, I'm actually going to leave this question out, but if you'd like to have a go at it, you can do so. It's very similar to the last shape that we did, but in this situation we have a compound pentagon at the end, so we'd need to work out that shape there first, which in fact we have. It's an equilateral triangle, we're told in the question, and this shape here is going to be our square, and then we've got all these faces to consider. So actually, once we've worked out our 1 and 2, we can then call this side A, another A on the other end, which is B, C, D, E, F, G. Okay. If you'd like to have a go at that as a little bit of extra practice, that would be wonderful. But I'm going to move on and show you what your task is for today. So, 2 tasks. First one is this. You can copy this table into your books, and I'd like you to match up the name of the shape that's on the left. Okay, there's a couple that we haven't talked about, but I'm hoping that you will recognize them. And then I'd like you to think about how to unfold that 3D solid. So that first one, the triangular prism, I've done for you. What shapes are the faces? So we've got 2 triangles on the end, and then it's got 3 rectangles. So we can write that in the center box. And then which net most represents it? Well, looking at all of those ones down there, I think C is the one that works. We've got our base, the 2 triangles on the ends, and then those 2 side faces. So hit pause, copy down this table, and fill it in. This is the first thing I would like you to add onto OneNote when the lesson is finished. And once you've completed that, this is your next task. Okay, this is surface area of a prism sheet. I am going to attach this sheet on to show my homework. It is up to you whether you print it out or you can just do a sketch into your books. And I would like you to show full working out for all of these questions. I'm also going to give you Thursday's lesson to work this out. So Thursday will not be an interactive lesson with me. I will be available on Zoom, but otherwise I would expect you to finish this sheet. So if you want to do that now, you can, or this evening, or before Thursday's lesson, you're very welcome to do so, but my expectation is on Thursday I would expect this full working out for these questions to be submitted onto OneNote. Okay, and that's the end of the lesson, and I will see you Thursday.